Okay, so for this video, we'll be discussing a few more examples that is related to composite function. Right, so let's have a look for example 21. Okay, so this is actually taken out from a quite recent past year, from February, March 2019. Alright, okay, so let's have a look. The function f is defined by this for the domain x smaller than 1. And we also have another function gx, okay, for x greater than 1. Right, so for the first question, they want us to express this in the form of x plus a squared plus b. So I think very obvious. This question basically is from chapter 1, where you need to complete the square. Okay, so we'll start here. X squared minus 4x plus 7. Okay, so you really make sure that in front of the x squared is a constant 1, right? So you can straight away complete square. Okay, so for x squared minus 4x, I copy the first two terms. After that, I will have plus something squared and then minus something squared. So what's the plus something and minus something inside? So I'm taking negative 4 divided by 2. And I'm having negative 2 squared minus negative 2 squared. And then the last term plus 7, I just copy it back, plus 7. Okay, after that, I want to combine the first three terms, become a one big bracket, okay, with a square outside. So I'm having one big bracket with a square outside. So the term inside should be x minus 2. Okay, then for the remaining numbers at the back, you just expand it out. So I'm having negative 4 plus 7. So from here, if you didn't do any careless mistake, by right, you should have x minus 2 squared, then plus 3. Okay, so this is how we complete square for a quadratic expression. Okay, so once we are okay with this completing square already, then now we proceed to the next part of the question. They want us to find an expression for g(f(x) and state the range of gf. So again, this is a composite function, right? Okay, so g(f(x) means that I want to put the function f into the g. Put the function f into the function g. Okay, so I will start here. If I want to put function f into the function g, so what is my function f? My function f is actually x squared minus 4x plus 7, right? Okay, and because of in first part just now, they already asked us to express the fx into a completing square form. And usually in our A-level question, right, you should know that what they want us to do in the earlier part, like part 1, part 2, usually we'll want to use the result maybe in the later part. So like for this one, instead of putting in the x squared minus 4x plus 7, I will actually put in the completed square form, which is x minus 2 squared plus 3. Okay? And after that, I want to put this x minus 2 squared plus 3 into the function g. So this is my function g. I want to replace this x by using this whole thing, x minus 2 squared plus 3. Okay, so let's have a look at how are we going to substitute it. So I'm having 2, then divided by the x I want to change become x minus 2 squared plus 3. And then minus 1 at the back, so I just put a minus 1 here. Okay, so from here you can see it is a composite function g(f(x). Of course, I can further simplify it where I will have x minus 2 squared plus 2. Okay, so after I find out this composite function gf, right, what else they want us to find? So you can see that they want us to find out or state the range of gf. Okay, so we come back to the previous concept, how to find the range for a certain type of function. Okay, if I have a look for this question, you can see that it is a reciprocal function for a quadratic curve, right? Because our quadratic curve is at the denominator, it is at the bottom part of a fraction. Alright, so this is a reciprocal function for the for a quadratic equation. So there are many ways for you to solve it, right? So in the previous few videos, I actually discussed how to sketch a diagram for a reciprocal function. Okay, so we can have a look here. Since I know that I'm having a basic shape which is an x squared, Okay, so now I will start to draw slowly so that you understand how I get the graph actually. If I want to draw x squared, that means basically it is a shape at the beginning. So this is x squared. And this is 0. After that, if I want to change it become x minus 2 squared, that means I'm trying to shift or translate the whole graph 2 units to the right. 2 units to the right. That means I will have a U shape like this. Okay, and then it will pass through for 2. So like what I mentioned earlier, if possible, right, we try to label all the x and y intercept, if possible. So to get the y-intercept, I let x equals to 0. If I let x equals to 0, then what do I get? I'm having a 4. Okay, then next graph. I want to sketch x minus 2 square, then plus 2. Which means that from this graph, I'm trying to shift the graph 2 units up. 2 units up means that I'm still having the minimum point at 2. Then just now, right, for this particular point, the minimum point is the x-axis, right, on the x-axis. So when you shift it up 2 units, the minimum point now will become here, which is 2. Originally, the minimum value is a 0, and now it becomes a 2. So that means this value is a 2. And then what happened to the y-intercept here? Just now is a 4. When you add or when you shift the whole graph 2 units up, then it will become a 6. And now, after this step, I want to sketch the diagram for reciprocal function 1 divided by x minus 2 square plus 2. Okay, so if I want to sketch this particular diagram, how will the diagram look like? Okay, so again, for reciprocal function, right, we learned a few important details where original graph, this is original graph. This is original graph. If my original graph is minimum, then in the reciprocal function, it will become maximum. So to me, right, when I draw, it is still a 2. And then I'm having a maximum point here. And what's the value for this maximum point? Okay, you have a look again for the minimum point. My minimum value is 2, right? Is 2. So when I want to draw a reciprocal function, you have to take 1 divided by 2, which means that this maximum point now is actually 1 over 2. I know that it should be a maximum point. Okay, then now at the end of these two graphs, right, the graph will keep on going up until infinity, positive infinity. On the right hand side also the same. The graph will keep on going up until positive infinity as well. Therefore, when I have 1 divided by infinity, it will become a very, very small value, very, very close to 0. That means if I want to sketch the diagram, it will getting closer and closer to 0, but it will not touch the x-axis basically. Okay, so this is how we sketch it. The same thing happened for the right hand side. My maximum point, from the maximum point, my curve will go down, getting closer and closer to 0, but it will not touch the 0. So this is what you have for the right hand side here. Okay, then again, like what I mentioned earlier, if possible, try to label the y and x intercept. So for the y-intercept here, I go back to the value just now. Just now my y-intercept is a 6. So now when I want to draw the reciprocal function, I will need to take 1 divided by 6. So this particular value is actually 1 divided by 6. Okay, then again, for the last graph that I have in my function, the composite function, I need to multiply the whole curve by using 2, right? Okay, now I want to sketch the diagram for 2 over x minus 2 square plus 2. Okay, when I multiply a 2 to the function, right, outside the basic function, basically we are having a stretch in y direction. So when you're having a stretch in y direction, it will affect the y value for my curve. Okay, so again, I refer to this curve now. I will label the same thing for all the value x. That means I'm still having a maximum point, okay, at x equals to 2. Okay, then now I want to observe the value for y. So the original value for y, the maximum value is 1 over 2. Because I'm having a stretch in y direction, right, where I multiply the 2 for the whole function. That means for this value of y, I need to multiply with 2. So 2 multiplied with half, I get a 1. Now my highest value here should be a 1 actually. Okay, and then for the y-intercept, originally I'm having 1 over 6. Okay, and I multiply it with 2, I will have 1 over 3. So if I try to draw this diagram again, I have a maximum point here, going down slowly and approach the x-axis, but it will not touch or cross the x-axis. Okay, the same thing happened here. I will have my graph going down slowly and then getting closer and closer to the x-axis also. Alright? Okay, and this particular y-intercept now is actually 2 multiplied with 1 over 6, and I'm having 1 over 3. Okay, so basically this is my curve for 2 over x minus 2 square plus 2. Okay, so after I have the idea on the diagram already, and now I want to try and figure out what is the range of GF. So before I determine the range of GF, I need to know what is my domain first. Okay, what is the domain that I need to consider? Okay, so now again, if I want to have the range of GF, I need to know what's the domain for GF first. Then I need to maybe try to imagine the arrow diagram in my mind. The composite function GF means that the function f comes first, followed by function g, right? The function f comes first, followed by function g. So the first circle here is actually the domain of f. This is the range of f, domain of g, and this is the range of g. And if I want to look at overall means that start from the first circle to the last circle here, I can straight away denote it by using the composite function GF. Okay, so if I look at the blue color here, the first circle of the blue color is the domain of GF, and the last circle here will be the range of GF. Okay, so from here you can see that the domain of GF is actually equals to the domain of F. So when we want to consider the domain for this composite function, we need to observe the domain of f. So you can see that the domain of f is x smaller than 1. Okay, so for this particular value x smaller than 1, I need to know when I'm having a 1 here, what is this value? Okay, so it's this value here when x equals to 1. Okay, so we need to do a little bit of calculation actually. Alright, so how can we do the calculation here? Okay, so I need to get my gfx. So I know that my gfx equals to 2 divided by x minus 2 square plus 2. And I want to know the value if I substitute 1 into my composite function. So what do I get? I'm having 1 square, which is a 1, then plus 2, and I get 2 over 3. Which means that when x equals to 1, my gfx here, this particular value should be equals to 2 over 3. Okay, then for the domain, x smaller than 1, that means if I want to observe this curve, right, I only want to observe the curve for this part, smaller than 1 part. Okay, so I will erase the remaining part here. So according to what we have, we actually only want to consider the red color graph. Okay, for the domain x smaller than 1. And now I want to find out the range for this particular curve. So you know that this particular curve, right, you're getting closer and closer to 0, but it will not touch the x-axis. It will not go below the x-axis. It is getting closer and closer to x-axis only, which means that the value is super small. Alright, and then the range, you can see that the highest value that we get is actually 2 over 3, but it will not include the 2 over 3. So basically from here, you can observe that this is the range of the composite function GF. Okay, right, so from this diagram, you can try to write out the range for the composite function GF, which means that for x smaller than 1, the range of GF is what? Is actually between 0 until the value 2 over 3. Okay, so how to decide? You can get it actually from the graph. Okay, so you can see that the graph is bounded or between the value 0 and also 2 over 3 only. They will not go beyond 2 over 3 and below the x-axis. Therefore, this is actually the range of our GF, composite function GF. Alright, okay, so you can see that when it comes to the part, if I want to find the range, right, I'm still focusing on sketching graph. Alright, so to me, I will get full use of all the concept that I learned earlier. Okay, so that it can help us to sketch the graph and also to understand from the graph what is the correct value for the range of a certain function. Okay, alright, so this is one of the example which came out quite recently. So it will be good if you know how to answer this kind of question. Alright, okay, so if no problem, then we will continue to example 22. So the next example, okay, example 22 and also example 23, right? Basically, their composite function is two different patterns. The first pattern is, okay, if let's say I have composite function gfx, right? Okay, it equals to a certain value. They already let you know the function f. They want to ask you what is the function g. Okay, where for example 23 is the opposite one. Example 23 means that they have the composite function f gx equals to something. They already let you know the function g, but they are asking you what is the function f. Okay, so that means example 22, it means you don't know the function inside. And you want to find the function inside. The function go first in the composite function. And then for the example 23, basically they want you to find out the function comes later. Okay, when you're having a composite function fg. Alright, so it is just a type of example, okay, to ensure that you know how to solve this kind of question. Alright, okay, so let's have a look for example 22. Okay, for example 22, I'm having the function fx, I'm having function gx, f gx equal to this one, they want to find the g. Okay, so for this kind of question, basically when we want to solve it, what we are going to do is we will write out the composite function first. So that means f gx means that I want to put the function gx into the function f. So my original function fx is this one, right? So like what I mentioned earlier, if the x I change become apple, then this one will become apple as well. Okay, and then now I want to make the x become gx. Therefore, the x here I also need to make it become gx, right? Therefore, if I write out the equation here, I'm having 2gx plus 3. Oops, sorry. So 2gx plus 3. Okay, and after that, what they tell us is the f gx, this particular function, right, the composite function is equal to 10x minus 9. So I will replace it here, 10x minus 9 equals to the 2 times of gx plus 3. Okay, so from the step here, right, basically you can observe if I try slowly to rephrase everything, okay, then I will get my function gx easily. Okay, so maybe I move the 3 over, so I'm having 10x minus 9 minus 3, which is minus 12. Okay, then what is my gx here? My gx here will become divided by 2 for the whole expression, so I'm having 5x minus 6. Therefore, my function gx is 5x minus 6. Okay, so basically this is a step how we actually find out the function g in the composite function fg, where they already give you the function f, they didn't give you the function g. Okay, right, so this is how we solve this kind of question. And next, let's do the other way around. If let's say they give us the composite function fg, we know the g and how to find out the function f. Okay, so we have a look for example 23 here. Okay, so they give us the composite function fgx. They also give us a function gx. They want to find the function gfx. Okay, before you can find the function gfx, right, you need to find the function f first. Correct or not? Because if you don't know the function f, how can you find the function gf, right? So you need to find the function f first. Okay, so to find the function f, basically the step is like this. So first of all, I will start with the function of f gx, and in the question it is given equals to 4x squared minus 2x then plus 1. And I already know my gx actually, so my gx is 2x plus 1. Okay, so for this equation, right, it means when I substitute the 2x plus 1, my final answer is 4x squared minus 2x then plus 1. Okay, and now my aim is to change this whole thing become a. Okay, so if I want to change this whole thing become a, become a simple variable, what happened here? Okay, we need to change everything here into the a as well. Alright, therefore what I do here is I try to let a equals to 2x plus 1, and I rephrase my equation. I'm having x equals to a minus 1 divided by 2. Okay, so after I let it like this, then I rewrite my equation again. F is still the function f. 2x plus 1, I already make it become the a, right? Okay, so I already make it become the a. So fa equals to what? So I'm having 4. The x squared, I want to replace the x squared by using a minus 1 divided by 2 squared. The same thing happens for negative 2x. I will change the x become a minus 1 divided by 2. And then plus 1 here. Okay, then I will want to simplify the whole equation here slowly. Expand the square. I'm having a squared minus 2a plus 1 divided by 4. Okay, so this one, if I try to cancel off the 2, right, I will have negative a plus 1, then plus 1. Okay, so next step, I want to continue to simplify this equation. I cancel off the 4. So I'm having a squared minus 2a plus 1 minus a plus 2. And end up, we'll get something like this. X squared minus 3x. Oh, sorry. A squared minus 3a plus 3. Okay, so now you can see that fa equals to a squared minus 3a plus 3. So this is actually my function f already. And usually when we write out the function f, right, we seldom write it out in terms of a1, right? We write out in terms of x1. So if you want to rewrite your final answer in terms of x, no problem. You can just write it as fx equals to x squared minus 3x plus 3. Okay, so because like what I mentioned earlier, after you get fa equals to a squared minus 3a plus 3, you can actually change the variable here anywhere that you like, just like f apple equals to apple squared minus 3 apple plus 3. So now I just want to rephrase it by using x. It's easier. Okay, usually when we want to show the answer in terms of for function fx, I will show in terms of x. So I will just change it become fx equals to x squared minus 3x plus 3. This is my function fx. Okay, and now we need to continue to answer the question. Okay, after I find out the function fx already, what they want us to find? They want us to find out the function gfx. Okay, alright, so you will find out the function gfx from here. Okay, to get the gfx, I need to replace the function fx into the function g. So what's my function fx just now? I get x squared minus 3x plus 3. So x squared minus 3x plus 3. Okay, substitute this whole equation into the function g. And what is my function g? It is a simple function here. So that means 2, I just copy the 2. The x, I will replace it by the whole function x squared minus 3x plus 3. And then plus 1, right? So I just put a plus 1 at the back. If I try to rephrase the whole equation here, by right, I should have 2x squared minus 6x, then plus 7. And this is my composite function gf. Okay, So if you try to observe the question here, I have done this part, settled. Okay, then now what do they want? They want us to find the value of x so that it satisfies this equation, fgx equals to gfx. Okay, so for fgx equals to gxf, I will start solving it up. So fgx equals to gfx. So what is my fgx? It has been given just now in the question. Okay, so I will let 4x squared minus 2x plus 1, and I let it equals to gfx. So what is my gfx here? This equation. So I will let it become 2x squared minus 6x plus 7. Okay, so very easily you can see that it's a quadratic equation. Alright, so if I move everything over to one side, I should have 2x squared plus 4x then minus 6 equals to 0. Further simplify it. Okay, and after that you get a quadratic equation in terms of x. Therefore, you can factorize and also solve it. Okay, so this is how we solve the question, example 23. Alright, where they give us the composite function fgx, they actually want you to find the function f that comes later. They give you the function g which comes earlier. Okay, and you need to know how to find the function f. Then after that, only you continue with the question. Alright, so this is what we have for example 23. Okay, alright, so for this video, we'll stop here. And next video, we'll be discussing also another 2 more examples that's related to composite function. But we will need to use the concept and idea on the domain, okay, for the function, the domain and range for the composite function, right?